Okay, so it's just after 1 o'clock. Sorry, 1 o'clock, 4 o'clock. Well, it might be 1 o'clock somewhere in the world, somebody watching this, but it's 4 o'clock here in Sydney. Some of you, that's my other computer dinging. Turn that down in a second. Yeah, some of you will have met me before in Intro to Mech, with some of the online stuff that I've created for you there. So I'm the subject coordinator for Fundamentals of Mechanical Engineering for the first time in a long time. Last time I did this subject, it was called something different. Yeah, so I should be able to see my screen share, hopefully, and you can see a rough run sheet for this online class. I don't like to call it a lecture. It's not, I don't want it to be a lecture. You've got all the lectures pre-recorded already. So you can see there just the approximate class times. I've just made a bit of a guess as to what time we'll get to various things. I've also indicated here for you, for example, the actual video lectures that are on Canvas, and we'll go and have a look at Canvas in a second, just so you can get a feel for where those resources are in there. Okay, so you can see there's about 8 questions in chat. Okay, so it's thanks for that, guys. So there was a quick question there. Will these lectures be recorded? Yes, I will record them. But there may be some delay in me putting them up online because I don't want to put up online another 2 hours worth of stuff that you think you've got to wade through. You know, the purpose of these sessions is not to provide you with another 2 hours of stuff. It's really just an opportunity for us to discuss things, for you to ask questions, yeah, and so on. So it's not meant to be, you know, exactly the same as what's on the pre-recorded videos. But yeah, so I will record them and I'll put them up. So while there is some chat, so yeah, so it's that won't be just Q&As. We'll just see how we go. As you can see in the run sheet on my shared screen there, you know, I've got some things planned for us to do, but you know, and as we go through them, if you're really on top of this stuff, you'll see it's pretty introductory. So the main purpose of this online class is to help those who need a bit more help, really. So you could pretty much complete the whole subject without ever going to a class.org if you want to. All right, anyway, so it's about 16:05. So what I'll do is just in regards to that, I'm just going to stop my screen share just for a second. Actually, what I would like to do, actually, before I go there, is it's really hard for me to keep an eye on the chat and everyone wanting to ask a question as I'm running the class. So what I would like is if I could have someone to monitor the chat, please. And if there's a question there that needs, you think needs answering, then I'll answer it. Or if you can see someone in the, I'm not sure where people can, no, I'd probably have to make you host to see if someone's got their hand up. But is there anyone who would like to volunteer to be the chat monitor for today's class? First one to yell out or put their name in the, say yes in the chat. All right, in the meantime, while you're having a think about that, otherwise, you know, if no one does it, I'm probably going to miss stuff. But anyway, let me stop this share. And what I would like to do is to just run a quick poll. Now, I've been hearing a lot about how students are missing a sense of belonging and interactivity and so on. So I'd just like to get your input on that. And I've got a poll here. So I think, can you see that? I guess I'll know as soon as I start seeing people responding to the poll. So, yeah, so I can see people responding to that. Awesome. So firstly, you know, they kind of ask the same thing in different kinds of ways. And it just gives me a bit of an idea of what you need in terms of, or what you think you need in terms of your learning. And it helps me to, you know, focus my resources where they're, or where you think you best need them. So I'll share the results. So I think you should be able to see those results. Yes, can you see the results? Someone want to yell out and say yes, please?
Yep.
Awesome, thank you, Nicholas. All right, so what you're telling me is that, you know, this sense of belonging is somewhat important to a majority and very important to some, but most don't think it's not important. And also the ability and the opportunity to be able to talk to other students about your coursework. Right, so yeah, and also the third question is really kind of asking the same thing. Okay, so someone said some people aren't feeling a sense of belonging here. Anyone want to respond to that? Is that my fault? Is there something that I should be doing different? Okay, so yeah, so Nicholas, just some people just come here to study. You're right, but very few people have said that in the poll. Okay, so you know, maybe you don't want to talk about this stuff. Maybe you just want to talk about the coursework. So we'll see how we go when we get to actually talking about. Yeah, okay. So not sure how I can judge the sense of belonging. Okay, that's a fair comment, but also giving you plenty of opportunity to talk. Maybe not so much to talk to each other at this stage, but yeah. All right, so let's stop that. I think we've let's see how we go with the next bit. Okay, so we've done welcome and okay, admin and Canvas walkthrough. All right, so I said I was going to do a Canvas walkthrough. Quick look at that. Just do a quick show if you know how to raise your hands in Zoom. If you know how to do that, just do a raise of hands quickly so I can just quickly see if you want me to do a Canvas walkthrough. All right, so I'm seeing a good number of raised hands for a Canvas walkthrough. All right, so let me do that. Let me find the right window and start sharing. Okay, one person says they're pretty straightforward, so if that person doesn't need a Canvas run through, then they can look at some of the videos and have their stuff turned off. Okay, so hopefully now you're seeing Canvas. So yeah, it's hopefully you know how to log in. It's via the same portal. If you go to UTS Online on the UTS website, you'll see the options for Canvas and UTS Online. So the home page is just a bit of a welcome from me.
We are studying today.
So we're so you can click in here. So, whoops, technical error has occurred. Yeah. In my student, that's a bug in Canvas. So let's try this button instead. Canvas. So that takes you into the assessment overview. And as you can see there, we've got very standard type of assessment structure. I've inherited this from previous runnings of the subject. So we've basically got five in-class quizzes and a final exam. As you can read here, I don't put all the due dates and everything in here because I try to minimize the number of places where I put duplicate data. But if you click back, you take it back out to the home page and scroll up here. All right, you see in your to-do list, you'll see those quizzes there, and also assignments are listed in here for you. Okay, any quick questions on assignments, assessment tasks? Okay, so there are some, so please just yell out and let me know if you've typed a question in the chat, because it's hard for me to monitor that, as well as, or if we've got a volunteer to do that for us, that would be great. So we've got in the chat here, will the quizzes be done in the lectures? Yes. So that's in the information there. Is it multiple choice questions? No, they're not. There'll be, let's just go back to assignments. So we can have a quick look at that and a quiz example. So I'll actually deliver them a little bit differently to what they've done here. This has been cut and paste from UTS Online, and I'm going to do things a bit differently, but the style of question will be similar. So you can see, you know, something like that. Okay? You would have seen these types of questions before in Intro to Mech. The structure in Canvas is in modules. So depending on the subject, it could be weekly modules, and I think most subjects tend to set up their modules in weekly mode like this, with topics for each week. Okay, so once you get in there, the navigation is pretty, it's designed so that you work through all of the, yep, there's a question coming, is there? No? Yeah, so you work through the content linearly. So you can, down the bottom here, you click next as you go through. Yeah. All right. There's your teaching staff, click next. All right. So you can just make your way through. This is really important. Please make sure you read this. I know I can be a little bit long-winded in some of the stuff that I write, but you know, this will give you a good idea of how the class is intended to run anyway. Yeah, so you can work your way through just linearly like that, or you can jump through to the various modules. If you're, you know, in week 2 and you need to go back and find something from week 1 or earlier, you can hopefully easily find the topic and get your help there. So let's go to today's stuff. In fact, let's go back to the previous page. All right, so each week we've got the pre-recorded lectures. Okay, and you would have heard that running before. So you can just click on those and run those. I've also included here for you the PowerPoint notes and some of the handwritten notes that go with that. Just in terms of using these hyperlinks, if you click on the hyperlink, that'll download the PDF. If you click on the little document with a magnifying glass, you can read that in line. Okay, so you can have that open, and you can be watching your video on YouTube. Okay, so that's all pretty straightforward. And then at the end of each week, you've also got the tutorial problems and solutions. Okay, so these are the pre-recorded tutorials from last session. Okay. Now, the tutorials, I see no value, well, I see very little value in redoing what you see in these tutorials, okay, this time around. Okay, so this time we're running the subject, we'll be getting you to do stuff much more than what you see in these these recordings from the online tutorials last session or last year. Okay. The way we'll probably start the tutorials is to get you to have a go at these questions in the tutorial. Okay, so you might have watched through them once, you may or may not remember everything, but in the tutorial, we'll say, okay, have a go at it again, but try and do it without looking at the solutions. Okay, and then we get you to work in pairs or groups or whatever. Any questions about the tutorials? Okay, thanks for that, Sarah. Yeah, I'll do that. So as you can see, and as I said before, you can complete the whole subject without ever talking to anybody, ever, if you like, if that's what you want. So I've done, set all this up, so you can do that if you like. So I can see there's a question in the... so I can see there's a question in the chat. Is the tute online or on campus? It's both. So there's the on-campus tutorial. So if you go to your My Timetable activities or whatever it's called these days, you'll see that you're allocated to a timetable tutorial. Or if we, let's go back to modules, we can go to accessing your online classes with Zoom. And you'll see the Zoom links. Okay, so for tutorials, what we'll be doing is there'll be an on-campus in-class tutorial, and in parallel to that, there'll be an online version, which will run. Okay, what I'd really like to do is to try and combine the two. At this stage, I'm not quite up to speed with all the technology and thinking through exactly how that's going to work. And I'm not sure I've got all the equipment I would need to do that well. So at the moment, they're separate. So if you're off campus and can only attend online, just attend online at that time. So can we attend the tute through the Zoom link? Yes, but it will be separate to the on-campus class. Okay, so there'll be a group of students on campus with the tutor, either Mubarak or Fatma, or you can attend online via the Zoom link, and that will be me with other students who are online. Okay. On the Tuesday morning at 9 o'clock, and I've already been emailing the people in this tutorial, some of them have responded. So because there are only 6 students in that class, we're going to run this just as a drop-in only. Okay, so a 1-hour drop-in, and that will be both on campus, online. So the tutor there will be in the classroom, but will be also online. So we'll try and manage the questions for both groups of students. And we'll use this as a bit of a test case to see how that goes with a few students, to see whether we try and incorporate that same method for both the other 2 tutorials. Correct, yep. So if your timetable says you're on campus, you can tune in online instead, yes. What I'll do now is, having discussed that, I would like your input into where you think you will attend and how you think you will attend. So we've got this little survey here. So if you can log into Canvas and be on this page, or you can just go to the this link that you can see on the screen here and use the code. So if we go to that survey, I used to see a survey that looks something like this. So if you can indicate, if you've done, there was a few students who have done this already. So if you've already done it, don't do it again. But just indicate where you think you will attend, or how you think you will attend your classes. Okay, so there was a question back on the question. Where can we find the Zoom links? Alice has asked that question, and I did show you that before. So if you go back to your modules.
Sorry to interrupt. I'll put the link in the chat.
Oh, good on you. Thanks for that. Yeah, so if you can't get the link, just grab it from the chat. Awesome, thank you. accessing your online classes with Zoom. Right, so here are your Zoom links. Yep. Okay, so most people have indicated that they're going to attend all or most of the tutorials on campus. So that's good. Right, so I think we're running a little bit behind now. We're 6:30. All right, so we are running a little bit behind. So we've done the polls. Any comments or questions on the polls or any other admin things before we jump into content? All right, so I'm not sure whether you can see. How well can you see this screen? Is that okay? Probably should have asked this.
Pretty good.
Pretty good? Okay. Just yell out if you need me to make it bigger. So this is mostly revision from physical modelling. So if anyone's got any particular questions about this, I'm just going to jump forward to the next thing I've got in the run sheet, which was a revision of moments. Just the other thing with these vector and projections of vectors and all that stuff, and whether you can remember Kramer's rule and determinants and all that, most of the 90% or maybe more of what we do in this subject, you can probably do without that. And to be honest, I'm pretty rusty on all that stuff myself. So if you're struggling a little bit at this stage with the vector stuff, don't worry too much, because most of the assessment tasks and quizzes, if not all of them, you can do via scalar methods. Okay? In later subjects, you'll need it, but in this subject, you can probably get away with not being fully on top of your matrices and determinants and all that stuff, right? Alrighty. So what I'm going to do before we get in, just to get a feel for where people are at, and just to give you something to do instead of sitting there listening to me the whole time, which is not what this is supposed to be about. I'm going to try now and put up on the screen some problems for you to work on. So if you've got access to Microsoft Teams, what I'm about to show you on the screen here, can you see that a picture of a question that says a beam structure is loaded at NB and me drawing on it?
Yes.
Yep, awesome, thank you. All right, so what I would like you to do, I could send you to breakout groups, but I probably won't do that. We'll see how we go just in the one big group. What I want you to do is have a go at calculating the moment effect of this force. So you've got a force. So we've got that force there of 250 newtons applied to this beam structure. Have a go at calculating the moment effect of that force about end A here. All right, so take a few minutes. So this should be revision from Introduction to Mechanical. So I'll give you, so it's 4:36. I'll give you to 4:40 to calculate what you think that moment effect is. If you've calculated, start typing in the chat what your answer is. Okay, so we've got two 35 Newton meter clockwises. Anyone else got a different number? So don't be afraid to put up a wrong answer. If you do put up a wrong answer, I may talk about it, but I'll never criticize anybody for having a wrong answer. And in fact, it's often good to have an incorrect answer come up, because sometimes it helps to draw out people's misconceptions and misunderstandings. So yeah, please don't be afraid to put up your answer if it's different to what other people have put up. And sometimes I deliberately ask questions that sometimes I deliberately ask questions that I expect the majority of the class to get wrong. So yeah. So thanks, Isaac. So yeah, I wish I was a true blue engineer. I'm actually really just a teacher, if it's honest. But anyway, that's another discussion for later. Okay, so let's have a look here. Let's go to my thing and see what we've got. So let's have a look at what our solution will be. So I think we all remember that to calculate a moment, it's the force times the distance. And what's the important thing about the distance? Someone tell us?
Perpendicular.
Pardon? Perpendicular, exactly right. So perpendicular to what?
The force.
Yeah.
The direction of the force.
Okay, yeah. Someone else? Slightly different worded answer. Line of action of the force.
Oh, there you go.
Yep, awesome. Thank you, Paulo. Paolo or Paulo? Okay, yeah, so line of action of the force. Okay, so who did the problem by breaking this force up into components? So yes, no. Yep. Okay, so yep, okay, awesome. Most people did it by breaking up into components. All right, so let's look at what I've done here. So I've got my component in the horizontal direction here, and what have I got next up? My component in the vertical direction. Who has their components drawn differently to this? There must be at least one person out of 61 that has their components drawn differently to this, or did not draw anything, just did the calculations. Who had a component up there like that blue one? Anyone? Top to tail?
Yep, I did.
Yeah, someone, okay, so I'm sure there's many people who had their component drawn like this. Okay, so, and that's something that physicists tend to do when they draw components. Now, it's not wrong, but when you're doing problems that involve the moment of a force, I tend to find that it can be misleading, okay? Because if you've got this force up here, and we're calculating moments about the point A down here, okay, it looks like this force perpendicular distance is 0.4 plus something, right? When in fact, the component passes through point B here, yeah? So just be aware of the fact if you're drawing your components like this, it can potentially lead to misunderstandings. So because we've got this 3, 4, 5 triangle indicating the direction, this 3, 4, you know, a few people have asked me, and if you see my videos on YouTube, there's some, often I get comments about where does this 3, 4, 5 come from. It's a thing that you see often in textbooks. I don't know, you know, the force is wherever it is. You know, it's not going to be in general 3, 4, 5 like this. But we like to do this in textbooks just because it's, you know, something to show you to use Pythagoras and so on. But anyway, so if you use the ratios of this right angle triangle to get this component, it's simply 4/5 of 250. Okay, and this component will be 3/5 of 250. If you're not sure about this and you need to check, you could find out what this angle is by doing inverse tan or inverse sine or whatever of these sides and do it that way. So if we want to calculate the moments about point A, remember we need to always indicate the direction of the moment. So we've got 3/5 times 250. So we're looking at this force here. It's tending to rotate about point A. So if we imagine that we're pulling down here, right? This thing is going to rotate around like this, around point A, yeah? Okay, so that's anti-clockwise. Right, so that's positive. And this one, we've got 4/5, so this component is acting here, so this is going to tend to rotate this thing in that direction around point A. So that's negative. So if we do the sums, we work out that we get minus 35, which means 35 clockwise, which is, I think, what most people have. Okay, so here's another one. So we've got a question here. Can I write an answer as 35 Newton meter clockwise moment? Yes, you can. So when you do the sums on that previous problem, you'll get a minus 35. Often what I'll do is to write next to that answer, this minus sign indicates that the moment is clockwise. Okay. All right, I'm going to send you all into breakout groups, just because, so you can have a chat to each other. Now, the problem that when I send you to breakout groups is that you won't be able to see this shared screen anymore. So hopefully each of you will have this question taken from the Teams site. So if you can go to the Teams site and get this document, I can't remember what it's called. Have a quick look. I think it's just called Moments Exercise 2. Yeah, Moments Question 2. We've got, so some people have run away because I'm going to create breakout groups. Suddenly lost 3 people. So we've got 60 people. Let's make 15 groups. Okay, so please join the group. Introduce yourselves. So there was only one group that I didn't end up jumping into too many groups because I got held up in one of them. But yeah, look, there wasn't a lot of discussion going on. You told me you wanted to talk to each other. All right, so what numbers did we get? So someone, oh, you probably don't remember your room numbers. Someone want to tell me the numbers they got for moments about A, B, and C, if they got some? Oh, okay. This time we're getting some different numbers. All right, all over the shop. Okay. Okay, what will I do here? Let me go through what I've got. So remember that, just before I do, in terms of sharing your answers, I think, did you see that when you were in the groups, I did some broadcast messages to all the groups. Did you see those? Just confirm that you were, yep, thank you. Yeah, so I said, look, at this stage, it's better to have a wrong answer than no answer at all, okay? As I was saying to one group, you know, we're not building a bridge, we're not building a tower with some cables hanging off it at the moment. All we're doing is finding the answers to the problem that I made up, okay? So, you know, take the opportunity to have a go and get things wrong while we're learning in class, so that you can find out the limitations of your understanding, so you can, and it's not just that, getting things wrong provides something for us to talk about. Okay, if everyone just gets it all right, there's nothing to talk about. But if you get things wrong, we can talk about why you might have got it wrong, and look at things that people don't quite understand. Okay, so let's start working through my solution here. What have I got? So solution. So we know that and some people said, oh, I don't know anything, I don't know what to do, but that's not really true. You know something, right? We've just talked about the fact that we know that the moment of a force is equal to force times distance. So even if you don't fully understand that right now, and while you're doing that problem, you know that the moment is equal to force times distance somehow. And in the problem, can you still see my screen share, by the way?
No.
No. Okay. Let me. Right. So now we've got the solution. So we know that the moment is equal to force times the distance. And as somebody said earlier, it's and as we discussed, it's the force times the perpendicular distance, and that perpendicular distance is the distance from the point to the line of action of the force. All right, so we know that much. So we want the sum of the moments equals force times distance. All right, what are we going to do with this 30 Newton force up here?
Split it into its vertical and horizontal components.
Yep. So most people are going to do that because usually that's the simpler thing to do. Okay. Because we're finding moments to point A, B, and C, the vertical component is going to pass through points A, B, and C, and therefore not have any moment effect. Right? So all we need is that horizontal component. So anti-clockwise is positive. I indicate that there. Okay, so there's my horizontal component. Just for completeness, I've put in the vertical component as well. Did anyone draw their component out there this time? No? Okay. Again, so just making the point that if you did draw the component out there, it looks like it's now offset from points A, B, and C, and you might be tempted to calculate a moment for that force. Okay. So, yep, someone put in the chat there the values of the components. Horizontal one is 30 sine 30 degrees. We don't need the vertical one, so I don't think I calculated that in my solution. So 30 sine 30 will be 15, which I think, so you can see, so that's where you might have got, I don't know if you just typed it in wrong or you actually had that wrong on your working out, but yeah, so you can see there that you may have got the solution incorrect just because you weren't properly concentrating on what you're doing, and that's all. You actually knew what you're doing, but you got just confused by where the angle was. Yeah. All right, so we've got so I've taken 20 times 1, so 2 minus 1 here to get that one, and that will be clockwise, so it should be negative. So I should have a negative out the front. Yep. And then I've got 10 here times its perpendicular distance, which is 3. So from that, there's 3. Yep. Why does neither of these two forces come into this equation? So I've got this force, the 20 Newton force, and I've got the 10 Newton force. What about this 30 Newton force? Why is that not? Okay, 0 distance, correct. Okay, so all good. I think most people would get that. Okay. So we get 10 Newton meters. So the moment about point A is 10 Newton meters, anti-clockwise. All right, so moment about B, how are we going for time? Right, so this point here, so this time we're going to have all three forces involved.
Hey, so real quick.
Yep.
Why did you put the 20 negative given it's supposed to be anti-clockwise as positive? Shouldn't it be the other way around?
So if we look at the 20 Newton force here, so that's the one you're talking about?
Yeah.
Yep. So if we're looking at about point A here, which way is this force going to tend to rotate this object around point A? So if we pin it at A and everything else was free, this will rotate like this, right?
Okay.
Yeah.
Yeah.
So taking our horizontal component here, so taking moments about point B, anti-clockwise positive, so we've got this one up here, about point B, its perpendicular distance is 2. So times 2, and it will be negative again because it's rotating clockwise about point B. Right, see that? So we've got our force up here, point B, that's going to go around that way. Yep. And then 20 times 1, so that's just this one over here times this distance, anti-clockwise. And the force down the bottom, 10 times 1, and that will be, so 10 times this distance, about point B, anti-clockwise. Yep. All right, and that equals 0. And then finally, moments about C. So 30 sine theta, I'll just put this up real quick, so hopefully we're getting the message by now. Because I want to get on to something else just quick. All right, so there's the solution, and after the class, I'll put this this solution up into that team site where I had the question as well, so you can grab hold of that and go through it. Okay, any questions about that before we move on? All right, so let me find the next thing I wanted to do. Okay, we've got a quick question. Why minus sign for MB? So for the moment at B, so I think you mean, just quickly, so this minus sign here. Okay, so if we go back to that one, we've got, so we're looking at this force up here, and we're looking at the moment about point B. So this force, acting around here, so moment about point B will tend to rotate this thing clockwise about point B. So therefore it's negative. Andrew, I hope that answered that question. Okay. Yeah, so do I have to mention whether it's clockwise or anti-clockwise? No, because we've done this here, right? So because in our solution, we've got these things, okay? That clearly indicates that if it's a negative sign, then it's the opposite direction to what we've assumed as positive. Okay, so that's in Intro to Mech. I don't know whether you only had me virtually as a lecturer or teacher. That's why I was so pedantic, if you like, about how you write your solutions, because it is important for you to be able to read someone's solution and understand what they've done. Is there a reason I set anti-clockwise as positive? I tend to always set anti-clockwise as positive because, or nearly always, not always, there's a question later in the module where I've done something different. And that's because if you have if you have an X, Y coordinate system like this, and if you do the R cross F, so that if you do the 3D moment equation, okay, which we haven't gone into, I wanted to get these basic fundamentals right. You can watch those lectures, and also the tutorials will go through that in more detail. But you do the vector moment equation is E equals R cross F. Okay, so it's a cross product. Okay, so if this is I and this is J, I cross J is positive K. All right, so positive K will be out of the page, right? And a positive moment is anti-clockwise by the right-hand rule. Okay, so yes, Hee-chan, it is set by the question, but you know the question could say clockwise is positive, but for me and for most problems, there's a good reason for setting anti-clockwise as positive. Yeah, if you do F cross R, you get a different answer. Exactly right. In fact, you get the negative, right? So you'll get the same value. I'm looking over here. So you get the same value, but you'll get a negative answer. Yeah. Right. So I think it's problem in the on Canvas in the module I think it's the example Lec1 5. The lecturer there talks about finding the projection of a moment along the x-axis, right? And if you do it the other way around, you just get the negative. Yeah. Running out of time. Right. So, but good questions. Thank you. Right. Let's move on unless someone yells out real loud. Okay. All right, so I won't send you out into breakout groups this time because we're running out of time. But have a go at calculating point A, B, and C. I'll give you, what time is it now? 5:33. 3 minutes, 5:36. And maybe put your answers in Newton meters. So those dimensions there shown are in millimeters. So just do your answer in Newton meters just to make the numbers a bit smaller. Okay, if you know about couples, you should be able to do this question in 30 seconds. Okay, so Cameron, I can see you got 50 Newton meters for A. What did you get for B and C? Right, so if you knew about couples, you wouldn't need to be still working on it. Now, that's not a criticism. I'm just leading into what I'm going to talk about. Okay, so 500 Newton meters won't be that much. So it's 0.2 meters, not 2 meters. Okay, Dean, 50 and 50 for B and C. Okay. Right, so the answer is 50 for all three. Okay, so the answer is 50 Newton meters for all 3 points. Okay, so good. Thank you, Nicholas. I got 50 for all three, but was confused why. Okay. That's because what we have here is what's known as a moment couple. Okay, so we've got two forces here, equal and opposite, and separated by a distance. Okay, so a couple, and you'll see this in the lecture video, we could have our two forces, F and F, and they're equal and opposite, but they're separated by a distance of D, perpendicular distance, right? Then the moment is always equal to the force times the distance between those two forces. Okay, so all we had to do in this problem was to calculate the distance is 250 times 0.2, and that's it, done. Okay, so if you'd done your moment calculations correctly for all the other cases, if you'd gone through step by step like we did in the previous problems, right? Like Nicholas did, so he got 50 for all points. He'd done the question, the calculations correctly, but wasn't sure why, right? And this is why. Okay, so when you have a couple of forces like this, right, then the moment is always the force times the perpendicular distance between them. And this also explains why when you see, so in the page on Canvas, I say on the page where I introduce couples, I say when you see a problem, and you would have seen them in in your past studies, right? When you see a problem that looks like that, so it might be 100 Newton force and a 500 Newton meter moment. Okay, so you'll see lots of textbook problems where a moment is applied to something like this. Okay, in my opinion, whenever you see that, you should always think back to where has this thing come from, and think that it's actually representing some kind of a couple. Okay, so what we see a lot with students trying to do equilibrium problems, for example, is that they want to try and multiply this number here by some distance or divide by a distance, right, when they're doing the calculations. Right? But if you try and remember that a couple is actually force times distance, where these two forces are equal and opposite, then hopefully that will help you not to make that mistake. I'm probably starting to confuse some, if not all of you at the moment, because I'm running out of time and would like to explain this a little bit better than I realise that I am. But if you go back and do those calculations and try and get them properly and think through this, hopefully that will help. The other thing that you'll see in lectures and in the textbook is that we talk about the moment being a free vector. Okay, so a moment we can put anywhere on the body and it will have the same effect when we're calculating the reaction forces and moments. Okay, so here we can calculate, doesn't matter where we calculate the moment, A, B or C, it's the same everywhere. Okay, conversely, if we put, now if we got rid of these and we applied 250, 250, 200, and we applied it there, the moment effect on that body is exactly the same. Right? If we calculated moments about points A, B, and C, we'd get 50 Newton meters. It'd just be hard to calculate, right, if you don't know about couples. Any questions? If you need to look up something, so I'm not sure whether you can do a search on the page. Doesn't. Oh yeah. Let's just try this. I haven't done this before. Search Canvas. Let's go couples. No. Okay, so you can find it that way. or you can try and find your way through the modules. Okay, so that's where couples is talked about in kind of lecture style. So the thing that we didn't quite get to here is equivalent systems. That looks like everyone's taken off. That's fine. All good. I can hang around for a little bit if people want to chat.
Hi, Terry, just a quick question.
Yep.
For the online tutorials that you'll be running on Thursday and Friday, I believe they are,
Yep.
Is there going to be any difference between those and on-campus ones, apart from physical and non-physical interaction?
Probably. What that difference will be, I don't know. You know, it's, you know, the tutorials won't be, you know, like you see in these recordings. So let's go on to the tutorial page. Right. So if you watch these tutorials, you'll see it was basically just the tutor going through the solution on the board.
Okay.
Right. So because we have these, you know, and even if we, you know, I would have done them myself, and you've probably seen my YouTube channel with dozens of problems done. Right. I see very little value in making you sit through at a specific time a bunch of this stuff. Right. If that's all you're going to get from a tutorial is sitting through someone going through a solution, you might as well just have it online and watch it whenever you want. Right. So what I would like the tutorials to be is much more like we got in kind of in the middle of today's session, where I put you in the breakout groups, you talk to each other. What you told me you wanted in the polls, right? You told me you want to talk to each other. So we're going to try and facilitate that. So, yeah, it's
Yeah.
yeah. So
Just another quick question. If we, so like, because I know like for other subjects, I don't have to be there every week on campus. Could we do like opposite weeks? Like you do online 1 week, on campus the week after, sort of thing? Or do you have to attend one or the other for the whole semester?
no, you can swap, but you know, I'm going to be always online, and unless we manage to do the combined thing.
Okay.
But yeah, so for the time being, it'll be me online in parallel to what's happening on campus in a physical classroom.
Okay, no worries.
Yeah.
Thank
so
you very much for today, Terry.
Yeah, no worries. You're welcome.
Thank you.
I just had one question.
Yep.
For the Friday tutorials, you know how they are online lectures, I mean online, that you can get online as well. If my timetable says that I'm on campus, can I still attend the tutorial via online?
Yes.
Okay. So I can do a mix of 50-50, so attending campus and attending online.
Yep, you can do whatever you like.
Okay, thank you.
Yep.
Terry.
Hey there, Terry.
Hey.
Sorry, I missed out in the first good 20 minutes. I had my computer laptop just crashed. I missed out on your introduction over the assessments.
Yep.
So just going over the subject outline now.
Yep.
There is 70% goes towards our quizzes and tests that you're going to be running at the start of the lectures.
Correct. Yep.
Yeah. Are these going to be electronic, or do we take a picture and send it in?
Yeah.
Okay, so it's like we'll fill it in electronically, but we'll still forward you a photo of our working.
Correct.
Cool beans.
Yeah, and
Right.
you know, some people like to work on iPads or tablets or Surface Pro or whatever. So if you're doing that, then you can just save that as a you know, a ping or a JPEG or a
PDF
or whatever, and upload that. Yeah.
Cool, cool. And are we going to be doing them at every lecture, sorry, or is it going to be in like scheduled weeks?
So so if you go on to, so in subject outline, you'll see that I've indicated the weeks, and hopefully if I haven't
Yep.
made a mistake when duplicating the data on Canvas, you should see in Canvas the those dates as well. So
Yeah, I've got it.
Yep.
So I've got weeks 4, 6, 8, 10, and 12.
Yeah.
Wonderful.
Yeah, and in Canvas, you actually get the proper date as well.
Oh, great.
Yeah.
All right, thank you. So the whole cohort will be doing this quiz at the same time?
Correct. Yeah, because it's at
That's
in the
All right.
lecture time. Yeah.
Yeah. All right. We don't have it. There's not a big cohort. Was there only 55 people or so?
Yeah, there's 100 and I think 109 enrolled in the subject. I think we had a peak of 61 students in the in this Zoom meeting.
Okay.
Not too bad.
Cheeky, they didn't show. Yeah. I'd say
Look,
audio, we're missing out.
Yeah, look, it's, you know, I've set it up so that you know, if you want to work independently, everything is there from week 1 to week 12. All the lectures, all the tutorials. So, you know, you could, if you wanted to, if this was your only subject, you could spend 1 week and do nothing but this subject and get it done, except for doing the online quizzes and stuff, of course. But you know,
Okay.
you know, my philosophy is to try and make it as flexible as possible for everyone.
That's nice. Okay, thanks, Terry.
Yep, no
I'll
worries.
catch you again next week if I don't catch you on campus.
Yep.
Cheers.
See ya. Thanks.
See you in the next week on the online course.
Yep. See you then. Thanks.
Oh, I think it's this week because the online tutorial should
My
be.
tutorials are this week. Yeah.
Yeah.
Yep.
I will. Oh, yeah. See you again on Friday. Thank you.
Yep.
Bye bye.
Yeah, bye.
Okay, so just wanted to clarify. So 9 a.m. Friday, is that a consultation time?
Sorry, which one?
9 a.m. Friday.
The 9 a.m. Friday.
1 hour session. Is that consultation?
Yeah. So the 9 a.m. Friday, because there's only 6 students enrolled. Normally, what would happen for a tutorial that has only 6 students in it? Normally, the school and the faculty would just cancel that tutorial completely, and then you just have to choose between one or the other of the remaining 2. So if you do want a full, so I've just left that as a 1 hour drop in for the 9 a.m. Friday 9 a.m. I've left that as a 1 hour drop in for those who can't make it to either of the other 2.
Okay, makes sense. Also,
so for six students, you know what tutorials are like. Sometimes half the students turn up, sometimes less than that turn up. So we can't afford to have a tutor at full tutorial rates sitting there for 2 hours doing nothing. But I wanted to make something available for those students who are unable to make it at any other time.